Hello, it's December 2nd, 2018, and this is going to be part one of a series where I'm installing a small miniature Microhydro turbine. It's going to be kind of slow going because we're getting into winter here because it's December in Pennsylvania. And surprisingly, we just had a downpour last night and it melted all the snow. Normally we'd have snow around here around now. At the end of the video and down below, I'm going to have links to other similar projects because it's going to take a while, so I want you to have something to watch. The first part of any hydroelectric scheme is to determine the stats of your location. I have it zoomed way in. You can kind of see way up there. That's local horizon, which is about where the spring is. I mean, you can see the light through the trees there, but not over there where the actual spring is. And this is mostly water that comes off of the spring. And what I have to do is determine two things really. Height or elevation or head meaning head pressure, and the second is flow. So we're gonna do that again today. And down here is about where I'm gonna put the turbine, which is kind of close to my house right there. And I could put it at a lower spot further down there, but this is really the most convenient spot for it because it's private. This is not a very private location. You know, there's businesses, there's a road that gets 20,000 cars a day. So down here it's kind of private and out of the way. Nobody will ever see it. If I put it down there or down there, there's two ditches on either side. Yeah, it's more visible. And I'm only gonna gain a few, maybe 10 feet of height. So I have to start by determining the base elevation, and we'll do that multiple ways. So it has multiple elevations there, and I'm going to confirm that with the map, and we're going to take an average and see how high we are between the top and the bottom. A few of the things I'm taking up with me: I have a drill, a little shovel, my tripod for the camera, and I have some wrenches and hole saws in here. I have two buckets, one that I'm going to use to measure the flow, and another that I'm going to use as a filter that I'm going to place up there. And this is just a temporary filter. This is not what's going to be used for the final system. And I got to take a shovel too, for two reasons. First, to get up the hill because it's really steep further up and wet and muddy. And the second is because it's so cold, I gotta dig that out, and I don't want to freeze my hands off. It kind of sucks. So let's go up there and see what kind of mess we can make. All right, it's getting steeper, and you can finally see the horizon up there. So that's horizontal, and that's where I'm going. And you can see my house down there. So I'm quite a ways above it now. Okay, I'm maybe halfway up. House down there. Spring up there. You can kind of see a little bit of a valley on the horizon. That's where it is. And I'm on the first logging road. There's another logging road a little bit further up. I'll go to that, over to another logging road that goes diagonally all the way up to the spring. I have another video that I'm going to put up here of me visiting this a few months ago, which is the last time I visited it. Give you a little idea of elevation and slope. Okay, there's my house way down there. Pretty much the steepest portion here. There's the logging road right there, and the spring's up there. Part of the reason I don't want to do it in the winter or on the shoulder season of the winter is, well, I physically can't get up here because it's so slick sometimes. Well, not sometimes, but it makes it a pain in the butt. So right there I slipped. And right there you can see that some other animals have maybe been slipping, or maybe they were digging under there. But there's signs all around here of other animals that have been slipping on the hillside, so it's not just me. Okay, I'm at the height of the spring almost. I mean, actually I'm a bit above it. It's right down in there. And I'm up here at the power lines. This is halfway up this hill. I know from down there this is the horizon, but the hill actually keeps going another 250 vertical feet that way, over a much shallower gradient. And I can see further off into the mountains now too. So that's cool. All right, let's go walk over and take a look at it. Let's grab my shovel and bucket here. Man, I'm tired. Woo! Okay, there's one of the pipes that goes down, but it's not connected. And here's the spring flow. Oh, we've got a lot. I don't think all that's going to fit through that pipe, which means there's likely more flow than I've been estimating. Wow, that's a lot of water. All right. Well, I'll set up my tripod and dig it out and we'll see what it does. Here's the old filtration, like, can or whatever. It's a welded piece of pipe. So that's not gonna work. And the owner of this said it's not potable, but I think they were collecting water straight out of this pool here. And of course that wouldn't work because you have all sorts of nature stuff going down in here. And he had talked about, you see a pipe there, and there's a pipe here, and there's some tin there too. He had talked about rebuilding a roof over this. But really, why? Because foreign material and microbes and whatever are going to get in there. It's just going to come down the hillside right here. So what I'm going to try to do is collect the water up there. And maybe I'll get potable water, and I'll get a little bit extra height of water too. I'm not sure what I'm going to do for the pipe or a collection barrel. I think I might dig it out and put it here, and then run a pipe out. The edge of the dam is right there, so I can dig that out some, and then run the pipe down here, and I'll connect my penstock, which is the fancy name for the pipe that runs down. I'll connect it out here, and then the owner of the property, he can also connect a pipe to feed his horses, or to water his horses from here. And the water goes way down there. Okay, I've made that all pretty muddy, so I'm gonna let that clear up some so I can see what I'm doing, see what progress I'm making. And now's a good time to check on the elevation that we were at. So on my phone here, sorry I'm not gonna show the whole thing because it shows where I am. You can see 1455, 1464, 1422. So these three elevations, they're one's GPS, one uses the GPS to check a map, and the other one uses an altimeter to see how high you are. So that's 3 ways, and I'm going to use a fourth way, which is I'm going to look on Google Earth and see what elevation it is at the top and bottom. So I've gotten varying numbers between 260 feet and 280 feet. So I'm going to take the average of all of them, and then we'll compare that to the actual pressure that we get once the system is set up. Another way you could do it, and I'll show a picture of what I'm talking about right here, is a handheld telescopic level. So you can walk across the terrain, sight the next spot up, walk there, and then keep doing that. And you know the height between your eyeball and your feet. So you add up how many times you do that, and then you can figure out how high it is. The problem with this magnitude of elevation is, you know, if my eye's at 5.5 feet, so 280 feet divided by 5.5 feet is 51 measurements. So if you take 51 measurements and each time you're off by 3 inches, that's 150 inches. Sorry, I'll put the metric numbers around here somewhere too. You know, that's 12 feet, and that matters a little bit. But really, GPS and the other methods I'm talking about are far easier than using a level, even an eye level, and doing 51 measurements. That's stupid. And the hole here is still kind of cloudy. All right, I dug some more. And, you know, that's kind of boring. So I didn't film it. It never really did clear up. There's just a lot of water in here. So somewhere in here is the pipe. There it is. I opened that up, and the flow here has reduced, and it's flowing out of this pipe. I don't know how big this pipe is. It looks like maybe 1 inch, but it's really hard to tell. I wish I knew. So that would give you a better approximation of what the heck's going on here. But I'll at least be able to get like a good flow, at least part of it. I may even have to come back up here, plug this up, and run a pipe to collect all the water that's bypassing the dam there. And then that'll tell me exactly how much water is flowing. I do not have a pipe up here, so I might have to come back. So this is approximately half of the flow in a 5-gallon bucket. Well, actually I have measurements on the side here. I'm going to verify that it is actually 5 gallons because I was looking at the size of these, and this is a different height from other buckets, and other buckets are different height from other buckets. So I'm going to see exactly what this is, and I have the stopwatch here. There we are, 18.26 seconds. So I just did the calculations on this. I have a TI emulator on my phone, and this is the one I used all through college. So 60 seconds divided by 18.2 seconds, and that gets us 3.28 buckets per minute times 5 gallons is 16.4 gallons per minute. Now, mind you, this is only half of it. You take 16.4 times the height, which is, I'm estimating in the low end here of 260 feet, times a constant of 0.18, and that gets all the units in line. And that's 768 watts. Now, minus efficiencies, you're still looking at, I don't know, 500 watts, maybe more. And that's only half the flow. So this might have turned from a 300 watt system to, in the 4 months of winter, being a kilowatt system. So just for reference, our house is all electric, everything 100% electric, but it's super insulated, you know, pretty efficient. This water flowing here would be enough to power 100% of our house in the winter. and a good portion of it in the summer. Because during the summer it reduces down to just a fraction of this, so maybe 200 watts. I don't know if that would be enough to run our house, but it would get pretty close. Now, instead of going down and getting a pipe, or I could have come up a little bit more prepared, because I was expecting all the water to flow through that pipe, but it's not. So what I could have done is also brought something called a rectangular weir, or a V-notch weir, which is just a board with a notch cut out of it, and you measure how high the water is up that notch, and then you can look at some charts and see how many gallons per minute that equates to. I should have brought one of those up, and I don't have anything here to create one. I have like a utility knife and a bucket lid, but I don't have a tape measure, so I wouldn't know how high. But I could mark it, because I brought a Sharpie. Yep, so instead of running back down the hill, I'm gonna sacrifice a bucket lid, because I have a bunch of those. And I'm gonna make a V-notch weir. And I'm gonna stick it in there, and we're gonna see how much water we get flowing through it. Okay, I was not expecting to have to build a V-notch weir. We'll check to see how square that is, but to my eyeballs it looks pretty dang square. And I'm gonna put this in here and pack some clay around it, and I'll plug the pipe, and then we'll see how many, or how high up this slot it goes. Hopefully this is high enough. If it's not, I can cut it a little bit deeper. And what I just dug out is pretty good clay, so I'll use that to plug this up. I also have to put clay behind it. To prevent it from falling back. Really, stones would be better, but not that one. Because the clay, and I've done this before, actually when I was doing my water wheel dam, I built a dam out of wood. And the wood, like I would jam it in with clay, but the water pressure would push the clay back, causing leaks around it. So you really have to support it with something that's firm. And a little bit of clay to clog up the pipe. Okay, I think the flow has kind of equalized. I got some leaks though, and I don't know that I'm going to be able to plug them all up. But it looks like the water's maxing out about here, and I'll mark it on both sides. You guys can see it right there, I marked it. So I'll have to take a measurement and see how high that is later, and I'll tell you down in the shop what that is. Alright, it's on, but it's tilted a bit. So I have to dig out on the far side. Okay, that's on. Now what? Just gotta find a big rock to put on there. Like this one. Okay. Now lots of water should be filtering through the bucket. I can kind of see it flowing around in there. You guys can't really because of the reflection. And we still have water flowing out of the pipe there. So I know it's still connected. And this bucket has cleared up a lot now. Let's see if I can get down here without breaking my neck. Slip and die! Okay. So now we can see in there. And you can see the pipe that the water's leaving out of. And that bucket should filter pretty good for a while. I'll have to think about how I'm going to collect this water, because previously when I was up here all the water was just flowing out of this little area here. But now it seems to be flowing out all the way even to over here. So, I don't know. I'll try digging it out and we'll see what there is. But that's for another time. Because I have to take this home and measure it, I took the offcut and I stuck it on the edge there under that rock. So that should keep most of the debris out. So, the first check is to see how square my square was. And it's off by maybe a 1/16 out of square over that distance, so that's pretty good. So I was just looking up the equations for V-notch weir. So this is a 90 degree, and the GPM, which is gallons per minute, is 1120 times H, which is the height, up to the 2.5 power. So our height here is, let's get this ruler lined up right across those. So our height here is 2 5/8. I hope that height is, H is in feet. 2.625, which is 5/8, divided by 12 equals, so this is 0.21875 feet. So I'll plug this in here and see what we get. So that is, at a minimum, 25 point, we'll round it up, 25.1 gallons per minute. Now you take this times my height, which I still haven't verified, so that's 260 times 25.1. Now remember, this 25.1 gallons, there was a little bit of leakage around the weir, maybe a lot, so it could be easily 30, but we'll go with this. So 260 times 25.1 times 0.18, which is that constant I was talking about earlier, is 1,174 watts. Or you could say we'll round up to kW. But now you have to take out your efficiency losses for the pipe and the turbine and electricity, so we'll just call half of that divided by 2. So that, what's flowing up there right now, could make 587 watts of usable power to a battery bank or an inverter, which I'm extremely happy about. The only thing I'm not happy about is to achieve this. I was doing some calculations, and I'll go over that in the next video. about the pipe. But if I was doing a 300 watt system, 300 watts usable, maybe 600 watts of mechanical power, that would be a 1.5 inch pipe. But for this amount of flow, 25.1 gallons per minute, which is kind of ridiculous, I'm going to need to at least go to a 2-inch pipe, which is heavier and stiffer and more of a pain in the butt to work with. Also more expensive. Which brings me to my next point. I do make a little bit of money on YouTube for this sort of stuff. I think I can show you guys how much I do make. And here we are. That's about how much I make a month on my water wheel videos. And that's enough to buy a few shop tools and accessories, organization stuff. But that's not really enough to put in a hydroelectric system. So I really need some extra money. The views from this video will help, but I have a Patreon account which I set up many months ago, but I have 0 patrons. Is it patrons? I don't know. So that's the end of that video. This outro is being filmed a few weeks after I recorded everything up the hill. I didn't like what I had recorded previously, so I'm redoing it. So I'm now treating my YouTube channel more like a business. So any money made in the business of my YouTube channel gets reinvested. The only problem with this project is there's a lot of capital expenditure that I need to make to complete this project. Running 800 feet of 2-inch pipe up the hill, that's $800,000 of pipe plus fittings, and then I also have to buy the turbine, do some cement work, electrical components. So it adds up. It's probably going to be $2,000, maybe a little bit more. And I don't have that kind of money sitting around or in my YouTube fund. So I'm asking you to support me on Patreon to become a patron for this whole project. And you can unsubscribe from me later if you don't like what I'm putting out. But for now, any money that you do put in would be greatly appreciated. A little addendum for something that I filmed up there, mentioning using like a sight glass to go from 5.5 feet to the next spot and just counting up. Well, you don't have to buy a sight glass. Chris Harbour, a guy that I'm going to mention in a little bit, he actually used a piece of clear vinyl tubing in a U or V shape on a stick, and he would hold that out, look for the water line, and that would be level. So then he'd walk to the next point where that water line meets up. An additional method of determining your height is to look at the pressure from the top to the bottom, and for that you would need to put in a hose, like even a temporary, like you could use garden hose. If you have long enough ones, you could link them together, or get some really cheap like 1/2-inch polyethylene or something to run from the top to the bottom. And a good reason to have that, because then you can have water that doesn't interrupt your hydropower at the hydro site. So like if you want to water a garden or mix concrete or whatever, then you have that additional water. You could also use that water line to measure the pressure or the water height at the intake. So if you're drawing too much water and your intake doesn't have enough water in it, you'll see a low pressure down at your turbine site. So you can put like a pressure transducer on your secondary or prospecting pipe, whatever, and that would allow you to, you're asleep. And that would allow you to adjust your valves or jets to harness as much of the power available as possible. For a little bit of context in this project, you might want to go back and look at some videos that I'll put up somewhere around here, or links in the description at least, of this hillside, this specific project. Before this project, I had another project at my old house where I built a water wheel, and it's gotten 2 million views or so, the whole project, probably more now. I know one video is at around 1.3 million views right now, and another's at like 800,000, so yeah, maybe 3 million views. It's a good project to watch if you have some free time to kill. There's a few other YouTubers that have been doing similar things to what I'm trying to do here. The first one I'm going to mention is Chris Harbour, and he's a guy from Wales that put in a 300 watt system in for his off-grid house. It's not connected to the grid, so no electricity. He does have internet, since that's a big contentious point, and pretty soon he's going to be upgrading his system to he estimates around 1 kilowatt, so that'll be approximately the same size of mine, but it'll be a low head, so it's only like 25 feet of vertical rise, but many more gallons per minute or liters per second than what I'm dealing with. The next one I'd recommend you go watch is by Mr. Hydro Head, and he has a whole playlist of him building his system where he has a multi-kilowatt system for his house in Colorado, which is also off-grid. Another guy that built a water wheel, his name is Henry Walker. You can see a little preview of what he's doing here. And he's not done with his, he's a little bit slow putting out videos, but if you look at the top banner of his YouTube channel, you can see that he actually has a motor mounted on there now. It's, if you look really close, you can see that it's a hub motor for a bicycle. But it's a really good water wheel build video that's similar to my water wheel build video, but a little better done, I'd say. And just a reminder, all of the links to these videos or playlists that I'm mentioning are in the description. The last one I want to talk about is Land to House. He does some pretty cool videos that aren't necessarily Microhydro. I know he wants to put in a Microhydro water wheel, but he doesn't quite have as much flow and height as a lot of other larger systems that are more viable. So he hasn't been doing a whole lot there. But if you're interested in something like ram pumps, go check him out. So after you watch a few weeks worth of those videos, if you're still watching or looking for something to watch, I also have compiled a playlist, and I have no affiliation to any of these people. They're not paying me or anything. I have a playlist of other water wheel videos, or not just water wheel, but Microhydro, and I've been putting it together for a very long time, many years actually. Just things that I come across, many that are not even English. A lot of Hispanic videos are on there actually, from like Central America and whatnot. So that concludes that video completely. I would ask you to give me a thumbs up, hit that like button, and leave a comment down below, and also hit that subscribe button. I think it's going to be over here somewhere. And the more subscribers I have, the more promoted my video is on YouTube, to have other people watching it too. And last but not least, please become a patron of mine on Patreon. That'll really help this project get going. Come March or so, maybe April, when things have dried out some and it's getting a little bit more daylight. Because right now, a lot of my time is spent watching Brenna here, and if I'm not watching Brenna, then it's probably dark out. Because then Mom's home. So Mom's watching Brenna in the evening. Sometimes, we share 50-50 in the evenings, but during the day, she's my responsibility. And it's actually kind of snowing right now. So I'll see you around.